I know, dear. No one cares about me. So.
We could switch to the style.
Care about you next year.
No one still cares that my air conditioning doesn't work, though.
You want me to say something?
You talk to Mr. Burgess. Anybody good buddies with Mr. Burgess? You tell him. Miss Dixon's dying.
I'll probably run the air conditioning.
I sent him an email and they told me Mr. Samsel wasn't working because he had a little accident, but then I heard he was back. He was having he did like a boiler exploded on him or something, and he got burnt pretty bad. But I heard that he was back working some. But apparently he's the only person that can work on the air conditioning. So I got told, I don't think he's working. That was the email. I'll send this to him, but I don't think he's working, which was pretty much, we don't care.
Yeah, she sent like food.
I know. It's really,
How many sections are there?
I don't know.
With every teacher.
We're only going to do like 3-ish, maybe 4.
We're only gonna have a test over like 3 or 4 lessons.
There's not that much time left. And this one isn't so bad. Substitution, you do substitution. If you got the question right on your test about eliminating the parameter, you did substitution, because substitution is when you solve one variable and you plug it into the other equation. Remember, when you're solving a system of equations, you're solving equations and trying to find what point they have in common or where they intersect. In Algebra 1 and Algebra 2, you only dealt with linear equations, and like I said, we're just expanding that a little bit. But I want to remind you that substitution is not a bad way to go. If I was going to do substitution here, which is the best letter that I could solve for? In the top or the bottom? Yeah, you don't want to get fractions. If you're going to get fractions, substitution is not the way to go. But we could solve for this, and we could say that x equals 4 minus 2y. And the good old substitution property says that if x equals this, then I can take that and plug it in for x in the other equation. Isn't this so nice and refreshing from limacons and polar coordinates? I know, right? In second hour they said, this is so easy it feels wrong. And I said, no, it's supposed to just be like, I can breathe. So all these AP tests, I can just do substitution and get 6 times 4 minus 2y minus 3y minus 4 equals 0. And now I can solve that equation because it's all in y's. So I'm just going to distribute. And don't make any silly algebra mistakes. I've been teaching ECA lab all year, so this is what I always say to them. So since the y's are on the same side, what do we do? And they say, add 3y to 12y. No. They always want to do the opposite. I don't know how to teach them this, that you don't, it's on the same side. It's just negative 12 minus 3 is negative 15. That's right, sorry. I'm just venting my frustration here about ECA.
At least you don't have to teach them. Unless they have to retake.
At least some of them come to class, right, Taylor? I kind of yelled at Taylor in the hallway because Nick did not come to class today, and it's a practice test! But apparently he's on a field trip, but Morgan Grudlock told me he was turkey hunting. And I might have had Morgan get his phone out and text Nick my thoughts about that. So. Morgan sleeps every day, so you know.
I remember Miss Morgan used to yell at him all the time for sleeping, and he's like, try to stay up, you're expensive.
Did he kick him out of his class?
Yeah, wasn't he only in the first semester?
Yeah. He didn't kick him out. He just failed. So.
That's a good way of putting it.
I will.
Once we find y, are we just plugging it back in?
Yeah. Remember what we're trying to find here is a point. We could have graphed these two equations. Graphing is not the best method most of the time. It's going to be pretty hard to tell where 4/3 is on a graph. But don't forget you're finding a point. So Colton said don't forget that you have to plug that back in and solve for x. You could plug it in here. You could plug it in here. But to me, the smartest place to plug it in is right here because it's the least amount of work. And I could say 4 minus 2 times 4/3. And don't forget you have a calculator, so don't freak out too much about that. 4 would be 12/3, so 12/3 minus 8/3 happens to be the same number. You can write your answer like that. If you prefer, you can write it as an ordered pair, because that's really what you're finding. If we graph those two lines, that's the one point where they would intersect. And we are doing more than just linear equations, but remember that sometimes when you solve a system of equations, there is no solution. If it was linear lines, remember if they're parallel, they're never going to cross, so it's no solution. We're going to do some circles. So a circle and a line might not ever cross because the circle might just be far away from the line. Do you remember what happens when you solve it using algebra if it's no solution? Like what happens when you do that? If you get, like, your letters drop out, I'm going to show you this because we have some issues in the second hour. If we were doing substitution, let's say we got something like 7y plus 12 minus 7y equals 6. Like you did substitution and you ended up with that. If your letters cancel out, then it's either going to be no solution or it could be infinitely many solutions. And remember, the infinitely many solutions is like if you had two of the exact same line and you graph them, they share every point. How do you know the difference? Like, what's the answer to this? Is it no solution or is it infinitely many solutions? Because 12 does not equal 6. 12 will never equal 6. The answer is no solution. If your letters drop out and it's infinitely many solutions, you would be left with a true statement, like 6 equals 6 with no x's or y's left. That's always true. So that means every number works, which would mean infinitely many solutions.
Could you just say all solutions?
Sure. Yes.
Can you go back to George? Didn't you just do whatever it's called where you like
Elimination. Where you're canceling them out, is that what you mean?
yeah, where you like multiply the bottom one by 6?
Yes, yes. We're going to do that eventually also. I mean, in a minute.
Well, that's just so much more.
It's great, but we're going to do some things that are not lines, which means some things are going to have x squared. Like one equation might have x squared and one equation would not have x squared. You can't do elimination if you have letters with different exponents that don't match up. So I just want to remind you that substitution is another way to do it. But yes, elimination, most people like elimination better. Elimination works great if they're both linear or if they were both circles because you could cancel out your x squareds and your y squareds. But sometimes you're going to be stuck with substitution. But yes, I believe maybe I have one more substitution. This is an example of one that you could not do elimination on because you couldn't eliminate all your letters on this because the exponents are different. This is something that you did not do in Algebra 1 or Algebra 2. This is a polynomial function, which means it could look a lot of ways. Like we could find a zero, a whole lot of stuff we could do here. And this is just a linear line, so I want to see how many ways or how many places that these intersect. Substitution is a great method here because if y equals negative x, I can just replace this with negative x. In second hour today, they wanted to divide by x. They said, let's just divide everything by x. Bad idea. Just like with trig functions, it was never a good idea to divide by sine or to divide by cosine because you lose an answer. If you divide by x here, you're losing an answer. And so factoring is the better choice here when you're trying to solve as opposed to dividing something out. I would add my x over here so I can put those together. And anytime that you see a problem and you think you want to divide by a letter, that just means factor it out instead of dividing, because really that's what factoring does. So I'm going to divide an x out front, so I could be left with that. And what's made to there? And remember, if you can factor, you can just separate it, which means I could tell you that one answer is x equals 0. If you divide it by x, you lose that answer. The other answer is the solution to this, x squared plus 3x plus 3 equals 0. If this is factorable, then definitely I'm going to factor it. This one's not factorable, and so you have to think about what your possibilities are here. We could complete the square, we could do the quadratic formula. But if this is an imaginary answer, do you agree that it's not part of the solution to the system? Because I can't graph imaginary numbers on a real graph, right? I have to have a complex and imaginary axis. So if this turns out to be imaginary, you can just stop because I don't really want the solutions if they're imaginary. So in second hour, we decided to complete the square just because we've been completing the square with circles. And I stopped as soon as I realized what was going to happen here. Because if you take half of 3 is 3 halves, and you square it, you get 9/4. If you add 9/4 on the other side, that's like 2 1/4. Do you agree that this is going to be negative? So when you take the square root of both sides, it's going to be negative. If you didn't realize it at some point, you should realize you're going to have a negative number over here. So I just stop, like I just cross it out and say I don't have to keep solving it because it's an imaginary number. Which means this graph only is going to have one point of intersection. Am I done with this problem though? No, I got to find the y that goes with it. This one's super easy because if x is 0, y is 0, right? Notice that if this was factorable or if this wasn't imaginary, this could have had 3 points of intersection. And so that's the new part. Like, I don't really know what this graph looks like. But it could have looked like this. Yeah, like this. Like that graph could have looked like this. And then think about like a line going through it. Like it could have crossed 3 times. So you could have had 3 solutions. It could have only crossed 2 times. You could have had 2 solutions. I know, but I'm just kind of making it. This graph doesn't look like this anyway. But just be aware that you could have more than 1 point of intersection, which is the new part with not dealing with just linear equations. But you're right. Most people like elimination when they can do elimination. So we'll just remind ourselves of that for a minute. Then do all the circles, and then do a story problem, and then be done. I just plugged it back in. I just did it in my head. If x is 0, you plug x in, then y is 0. So that means that those are only going to intersect at the origin. Sometimes substitution is a terrible idea because, like in this problem, if you tried to solve one of those for x or y, you're going to get a lot of fractions and a lot of ugliness that you have to substitute in and try to keep track of it all. It's not impossible to do substitution. It's just really not that easy to do substitution, which is why we like elimination. Elimination is when you make one of the letters the same and then you add or subtract to eliminate the variable. There's lots of ways we could do this problem. We could make the x's the same. We could make the y's the same. We could make the x's so that we subtract. We could make them so that we add. It just depends on which way you want to do it. So let's make a decision. We want to make our x's the same or our y's the same? X's. If we're going to make our x's the same, the first number that 4 and 3 share is 12. I like to add as opposed to subtract because I think people make mistakes when they subtract because they forget to subtract everything. So for me, if I multiply the top by 3, and that's going to become a 12, I'm going to multiply the bottom by -4 so that I'll have 12 and -12 and they just cancel out. If you multiply the bottom by +4, that's okay. You're just going to have to remember to go through and subtract everything. So again, lots of options here. You could make the y's the same, and we'll still get the same answer here. Just don't forget to multiply through everything. So I always just rewrite it over here. 12x minus 15y equals -69. And on the bottom, I get -12x minus 16y equals -24. And someone in second hour said they multiplied the top by -3 and the bottom by +4 because they thought that was a better idea. You know, again, as long as you're doing the algebra correctly, there's lots of ways to do this. But when I taught Algebra 2 and even Algebra 1, I always recommended doing this because now I can just go through and look at the signs and not have to think about subtracting because these are going to cancel out. -15 and -16, -31y, and -69 and -24 is -93. A lot of these are going to work out nicely, but just like the first one, don't be scared or don't think that you're wrong if you get a fraction, because we could have fractions also. But this one works out really nice to be y equals 3. Definitely lots of room for arithmetic errors, but the process is really what I'm looking for here. We got to find the x that goes with this. So again, you can take that and you plug it back in here, or you can plug it back in either one of these. I always go back to the original because I feel like I can deal with smaller numbers better, and it doesn't matter. You're going to get the same answer no matter where you plug it back in. If I plug it into the bottom one here, 4 times 3 is 12. So if I subtract 12 over, I get -6. So x equals -2. And so those two lines would intersect at the point -2, 3. Questions about that? No trig, no polar stuff, no thetas. Oh my goodness. Only 90 degrees. That's all we have to deal with.
So we like stop with trig.
Oh yeah, pretty much. I mean, it's on your final, but we're taking a little break from trig for now.
So until next semester, pretty much.
Your head just seemed like it was down just a minute ago. You have to do trig, basic trig in calculus. Like you need to know your unit circle. You need to be able to remember that sine squared plus cosine squared equals 1. But there's no polar coordinates in our calculus. Like if you went on to calc 2 or calc 3, you'll do some of that stuff. But, you know, basic trig stuff. And we'll review it. We have a day of review of trig in the beginning of the year in calculus. But
How many singles are there?
what, a single day? How many what?
How many like?
It depends on the college, but I took calc 1, calc 2, and calc 3. Some places have calc 4, I guess. But
What's the highest?
I don't know. I mean, it just depends on what you're doing. Math just gets crazier and crazier, so.
Cameron Chestnut is in Calc 4.
Calc 4. Calc 3, when I took Calc 3, it was mostly dealing with three-dimensional stuff. So, like, everything I did in calculus with x's and y's, we were now doing with x's, y's, and z's, and making three-dimensional shapes. It's kind of crazy, but I don't really remember that much of it. Calculus is what I started with in college, so it's kind of weird as a math teacher that I started with the highest level that we teach here. You know, like calculus is the highest level of math that not very many math teachers actually teach calculus. But that's like my first class I took in college, and then everything after that, you know, I probably took like 20 math classes, and like every math class after that was calculus was required to take the next class. You know, like it's kind of weird. There's just lots of crazy math. So that's why math people are so crazy. They do crazy, crazy stuff. I don't know the highest level of math. It just keeps going. It's infinite. Wow.
That's
so
how
high.
it's
I assume we have the can opener.
That's a good joke. I didn't write that joke.
What do you think of Zane's joke today?
I didn't even hear it. I really didn't.
I heard it.
Enthusiastic person. I did, yes.
Now it sounds like you're like looking for the life part. You click the background, you're like, I need a happy, enthusiastic person.
No one listens to this anyway, so.
I listen to it.
No, you don't. I know, but you don't go home and listen to it. And if you did, you would be like skipping ahead until I started writing again. I know. I'm on to you.
Okay, so the other day when I was actually looking for one of these videos, I was on my phone, and I like typed in the search Tiffany Dixon. There are some interesting people with the same name.
Wow. I witnessed it.
I showed her.
YouTube Tiffany Dixon, and it should be better.
Yeah, well, I was.
There's some not
and it was
me.
some large lady taking a selfie. That was also named Tiffany Dixon.
It's kind of weird how many people have the same name. Like, it's weird. Like, if you ever Google your name, it's creepy to think about.
There's a professional goalie. Yeah, it's named someone else.
So, you know.
I feel like maybe we should like read that because it's
I'm not.
pretty.
I'm not gonna Google to that extent.
Yeah, she was cute.
Can we do elimination on this problem? No, because if all the letters don't match up with another letter, it doesn't help. Even if you try to eliminate the x, you're still going to have an x squared and a y squared, which is not going to be pretty. So if the letters don't match up, you have to do substitution. First of all, and this says check graphically, which means we're going to graph this eventually also. What kind of graph is this going to make? A line. What kind of graph is this going to make? A circle. We just did that. That's why we did circles on Wednesday, so we could do these problems. So if you wanted to, if it says this on the homework, you could graph it first, and maybe you won't have to do the algebra if it crosses at a nice point. How many ways could a line and a circle intersect? 2? Could they intersect less than 2 times? Could they intersect 1 time? And a line. Could they intersect 0 times?
Yeah.
Yes. So it could be 0, 1, or 2, just depending on what happens here. I think the best choice is to solve this for y and say y equals 4 minus x. Could you solve this for x? You could. It's going to be more work. Because I like this idea because I only have to plug that in we solve this for x, we'd have to plug it in here and here, right? So I'm trying to make the least amount of work. Second hour, they said they're just really struggling because anytime they see x squared plus y squared, they just want to write r squared, but we're not doing r's, no polar. Stay away from the r right now. Just say no to r. Till we get to finals, and then we'll have to all put it all back together, right? Oh, so excited.
How many days in review are we?
Like 3, 4 maybe. FOIL this out. Don't make silly math mistakes, right? That's going to be 16 minus 4x would be minus 8x plus x squared minus 4x, right? There's 2 of those there. It's not just 16 plus x squared. And then anytime we have an x squared and an x, that's going to be a quadratic equation. So I could put those x squareds together and say that's 2x squared, negative 8x and negative 4x is negative 12x, plus 16 equals 0. And again, quadratic formula, complete the square, factoring are all options. I see that this is all divisible by 2, and you can't divide by an x, that's a big issue. But you can't divide by a number, it's just a common factor, which means I would divide all this by 2 to make my number smaller. So that's going to become minus 6x squared plus 8. And then that's pretty easy to factor, right? 4 times 2 minus and minus, which means I get x equals 4 and x equals 2. And we said a circle and a line could intersect 2 times. So could we plug those back in somewhere to find the y's that go with those? Yeah, you can plug it back wherever, but I'm going to plug it back in right here. If x equals 4, then y equals 4 minus 4. So that's going to be y equals 0. And if x equals 2, then y equals 4 minus 2. Y equals 2. I'm going to graph this also just because it says to check graphically. Linear line, that's just a slope and a y-intercept. I already solved it for y, so that's going to be a y-intercept of 4, a slope of negative 1. Can I graph this circle right now? X squared plus y squared minus 4x, or what do I have to do first? Yeah, we got to do what we did on Wednesday. We got to complete the square to put that in standard form, so I'm going to do that over here. X squared minus 4x, leave a spot, plus y squared equals 0. So that would be a plus 4, and I put plus 4 on the other side. So that would be x minus 2 squared plus y squared equals 4. And that's why we did circles on Wednesday, even though we're not doing the rest of the conic sections, is because circles shows up in this chapter, and I felt like we need a little refresher on that. So now I can say that the center of this circle is at 2, 0, and it has a radius of 2. Which we can verify that our answers were correct. It crosses at 4, 0, and 2, 2. What if I had a parabola in a circle? How many ways could a parabola in a circle intersect? Lots of different ones, right? Like it could be never also, right? But I think the most would be 4. In second hour, they tried to argue with me that the parabola in the circle could be infinite because this parabola could line up perfectly with the circle, and I said that's wrong because there's no way that a parabola will ever be the exact same roundness as a circle. And they said I was wrong, and I told them to prove me wrong, and they told me to prove them wrong, and that's where we left it. But I know I'm right. It's too, like, a parabola goes out too much. Like, it's just, it would never, like, I just don't think that it could ever work. It's not gonna, it can't happen, I'm telling you. I don't even want to waste the time. What else do we like to do with this? We like to look at story problems, especially talking about profit. So let's look at a story problem. Just to remind ourselves that we know how to do this. Some good old algebra here. This is on the ECA. We're maybe not about very much. This is on your, going to be on your test. I wish I had some Dairy Queen right now. Dairy Queen invests $5,000 to produce a new blizzard. You don't really have to write all the words for this down, right? Like, you just need some important stuff. We're going to invest $5,000. Blizzards are going to sell for $3.49, and it costs $2.16 to produce each blizzard. And so they ask you how many must be sold to break even, and how many must be sold to profit $8,500. Break-even point is a big thing that we talk about all the way back in Algebra 1, because if you're trying to sell something, it's important that you are making money off of it, which means I think it's important that you're doing more than just breaking even. But breaking even just means that the amount of money that you're putting into it equals the amount of money that you're bringing in, which means it's a perfect system of equations problem, because basically it's when your cost is equal to your revenue, because revenue is what you bring in. So I kind of did this in second hour. I made up two equations, and I said we could set them equal to each other, and then they're just kind of doing it all in their head. So I'm gonna do it the same way I did in second hour, but then if you can skip some steps, I'm okay with that. But basically, you gotta set up your cost function and your revenue function. And so I just use C for cost, and I just use X for the number of blizzards. You could use B or N or whatever you want to use here. But how much does it cost for me to make these blizzards? 216 per blizzard, right? So how would I write that in the equation? If X is the number of blizzards? Is that my only cost for these blizzards? What else? So it's like this startup fee of $5,000. And anytime you have a business or something, like if you're making t-shirts, then you have to have the whatever, the press thing for it, that's the cost. Or if you're renting a building, you have to have those costs. There's always these costs that are there once, and then so much per item. If you're making cookies, how much per cookie? If you're having shirts, how much do you pay per shirt? That's like a normal cost equation. And then your revenue is how much you're bringing in, which is just how much are we bringing in per blizzard? $3.49 per blizzard. And if we want to break even, that means we want these two to equal each other, right? That would mean we're not in the negative, because anytime you have a business, usually you start out in the negative and you have to work your way out. Which means you're just going to set these equal to each other. In second hour, they were kind of doing it in their head a little bit, because I said this. So I said 349x equals 216x plus 5,000. And they said, well, why don't you just say $1.33 equals 5,000, because the difference between how much you sell them and how much they cost is $1.33, and then you just have your 5,000. And that's exactly what I'm going to get from my equation. They just jumped right to that. And if you can jump right to that, I'm okay with it. You don't have to show all this work, but I just like to write equations. And if you subtract that over, you are going to get $1.33 equals 5,000. So to solve that, you're just going to divide by $1.33, and you got to sell a lot of blizzards. And I know this is a simple problem. There's really different sizes of blizzards, and we're just trying to make it simple. And if we're talking about number of blizzards, then we should round up to the next whole number, because you can't sell part of a blizzard. So you get a decimal here, but I'm just going to round up and say that's 3,760, even though it's 0.3. You round up because you can't sell 0.3 blizzard. Right, you're actually making a little bit of money, right? Right. You wouldn't actually, if you only sold 3,759, you actually would still be in the negative a little bit. So that's why I say you go ahead and round up. But you're right, you actually are getting a little bit of profit, a few cents. Part B is a more realistic goal. You don't want to just break even. You want to make some money. And so how many must be sold to profit $8,500? And again, however, if your mind works a way that you can get to this without doing all this work, I'm okay with it. But for me, I always think about profit. Oh, look, I totally stepped on this. Oh, it's right here. I really need some cord intervention. Profit is how much you're bringing in minus how much it costs. Your profit can be negative. So profit is always revenue minus minus cost. So if I want my profit to be $8,500, then I'm just going to take 3.49x and I'm going to subtract this. And I'm going to get that equation. Again, in second hour, someone said, well, why don't you just add the 8,500 to the 5,000 that you already have invested and then set that equal to your $1.33? Yeah, that's my equation. You're just thinking of it differently, so that's okay. So I think this turns out to be 13,500 equals $1.33x. And if you divide by $1.33, I think you get like over 10,000 as an answer. That's why it's hard to make money selling stuff. I told them in second hour, my husband and I used to say that someday we were going to have a restaurant because that was what we were going to do. We were going to own a restaurant because we both like to cook and we would make new recipes and be like, oh, this is going to go on our menu for our restaurant. But then we watched Restaurant Possible and we see how like people are in like $500,000 debt because their restaurant is failing, and like 2 out of 3 restaurants fail because they just can't make money. So we decided, no more restaurant. We're just going to have a food truck. And then it's not so much money to invest, and we can just go around to festivals, and that's what we're going to do someday when we're old and gray and our children are grown up. We're just going to have a food truck. And I can do the math to see how much stuff we have to sell to make profit. And again, would this be exactly $8,500? No, because it was 10,150.37. But again, we can't sell partial blizzards, so yeah. I got one more. You don't really have to write this one down. I just want to make sure that you're. Who's this guy at my door? Yes. Oh, thanks. Saj is buying a soccer card from me for part of her soccer team. They're selling these little discount cards, and she wants one. Pickup day's tomorrow, so today's the last day for giving money. She like sought me out like I wasn't a good salesman because she's like, "Are you selling soccer cards? I'd really like to buy one." And I said, "Oh, well, I'll figure out how to do it. I don't know what I mean." So. I just want to talk about this. There's one of these on your homework. You don't necessarily have to write this down. I just want to make sure you know what this means. I think if you know what equilibrium means, you probably could figure it out. But they like to give you supply and demand equations. I think if I remember correctly, it's about hair dryers. Maybe I'm making that up. But there's a question about the supply and demand of hair dryer costs. What do you think it means if it says find the equilibrium point for supply and demand? Where the supply equals the demand. So if they give you a supply and a demand and they ask you this, just know that, maybe just write this. Equilibrium point means where supply equals demand. And as long as you know that, you're just setting those equal to each other, or doing elimination if you prefer. And you're just finding x, like the number of hair dryers or whatever the problem has to be. So we'll let Ethan talk there, supply and demand. Okay, I'm not really going to work this one out if you're okay with that. I'm just going to give you the homework, which is on page 575 to 577. 3 through 30 multiples of 3, 53, and 58. We will not go over this on Monday because I will not be here, but on Tuesday we will go over it. Monday there will be retake tests or worksheets.
How long are the worksheets?
I don't know. It's just a worksheet. Yes.